Who can tell me what the meaning of refraction?
The bending of the light.
Yes, we said that last time, the bending of the light or the bending of the wave at the surface between two different what media. And why this happened?
Because light is slower in optically dense media.
Exactly, change its speed. Exactly, right. Thank you. So we're going to write this down. The change of the light or the wave direction. Bravo يا إناث. The wave direction at the surface between two different media due to the change in speed. Okay, so this is the definition. When waves moves from a dense medium to a denser, its speed changes. That causes refraction. شكرا يا إله. صح. So for example, if I have an incident ray like this, and this is the normal, or this is another incident ray, you can see that it doesn't change direction, only slows down. Okay, and there is air here, and there is water here. You can see that the direction, the angle of incidence, it's here, and the angle of reflection here, it changes direction. It's supposed to continue in this direction. It changed a little bit. Okay, so yes. Here you can use the 6 S's that I told you about before, but it's not. We are not talking about shallow water here. We are talking about optical denser medium. Okay, so what are the 6 S's here? Okay. Yes, what happened to the speed here? Slow, exactly. What happens to the wavelength? Tamam, short, excellent. What happens to the angle? As you can see here, look to the angle of refraction here. The angle, what happens to it? Exactly, smaller. Okay. What will happen to the frequency? Remains the same. Bravo ya Marwan. Shukran. What happened to the direction? It will bend towards the normal. This is the S. Okay, S, 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 and denser medium or slower. Yes, bend towards the normal. Yes, shukran. And the normal. This is the normal. It bends towards it. But if the ray was perpendicular, it will still where on the normal. Okay, so the angle is still 0 or in this ray. Okay, tamam. Only slows down. Only change. It slows down. Doesn't change its direction. Okay. Fine. So as you can see here, we have a light incident ray. As you can see here, two things happens for it. Some of the ray reflect, some of the ray what refract and keep its direction as it emerged. Now this one and the first one, both of them, they have to be what they have to be? Exactly, they have to be what? Parallel to each other. That's why behind any mirror, okay, or sorry, behind any glass, plain glass, okay, flat glass, okay, things do not change their position that much. Okay, tamam. Okay, so how we can do that? Why light actually do this? Why light changes direction? We said that because of the change in speed. Let me tell you, give you an example. Okay?
Change in medium.
Change in medium, yes, cause change in speed, yes. So let me give you an example. For example, okay, if I have, okay, a straight road, okay, street. This is the street like this. Okay, And this is a very traffic, okay, and the cars, they are very fast here, okay, and you want to cross the street from one side to the other, but you are running from this point to somewhere here on this point, okay. So what you will do, if you keep moving in straight line like this until you reach here, okay, now you can run as fast as you can in this position, okay, but as you reach the road, because you don't want to be hit by a car, you will what? You will change your direction since you are slowing down. You was running as fast as you can in the side road, but as you are in the road, in the street, you will what? Slow down. Then you can go whatever you want as fast as you can. Hold on, like this. Okay, after you finish the road. Now, as you can see, I did that in purpose. What I did here, I tried to what? To draw two different situations where what? The light changes its direction. Imagine that we are talking about not a road here. We are talking about what? A glass block, okay? And this glass, okay, let me write, this is glass block. It's covered with air. So we are talking to transfer from fast region, the light, to what? To slow region. Okay, the light slows down when it reaches the glass. So here, what's happened here? This is the angle of incidence I. Okay, this is the angle of incidence, yeah, different medium, exactly. This is the angle of incidence I, and this is the angle of refraction R, and this is also the angle of incidence again I, and this is the angle of what? Of refraction, what? R. As you can see, whenever you go to slow medium, what happens to the angle? Becomes smaller. And whenever you go back to the fast medium, the angle gets what? Bigger. Okay, so this is I, this is R, this is R, okay, I, this is R. If I'm talking about a glass block which has parallel sides, you will see and you will notice that this angle, I'm sorry, that this angle and this angle, they have to be equal. And also this angle and this angle, they have to be what? To be equal, yes. Okay, good. So who can tell me, who noticed what's happened between this direction, okay, and the final direction? What about them? This ray and this ray, what about them?
Same gradient.
Same gradient. We are not talking about graphs, but yes, they are. They have to be to what? Bravo, you are very close. They have to be what? What's the word that? Parallel, exactly. This is the original path, okay, and this is the final path, okay. They have to be what? Parallel to each other, yes. Okay. I was about to type that, yes, but I guess saying it's faster. No problem, Abdurrahman. Okay, تمام. Good. تمام. Take screenshot if you please. Okay. Mister, can you draw it upside down? Sometimes draw horizontal. Oh, no problem. You are going to draw it several times now. In this worksheet, you are going to draw a lot of things. Yes. No problem. No problem. Don't worry. Okay. Now, again, recall. For all refracted waves, the path is deviated towards the normal when the wave is slowed down and vice versa. Why is this? I told you now we are not talking about density here. We are talking about something called optical density, which we are going to talk about it in something called refractive index. And what's the refractive index? It's the ratio that they use it in physics, okay, in waves, to represent how much the speed of light decreases as it reaches a certain medium, okay? So the refractive index, the ratio of speed of light in vacuum to its speed through the medium. So each medium has a certain refractive index, and this refractive index, okay, they use letter N to represent it, equal speed of light in air over speed of light in the medium. Okay, now I'm going to teach you something, okay, that new, okay. Tu parles français. مين بيعرف يحكي فرنسي هون؟ Hands up.
Not me.
اي حدا بيعرف اوكي، ادهم بيعرف يحكي انجليزي، كمان مروان، اوكي فرنسي، سوري. اوكي طيب what do we say when we want to say in French language, okay, this is life? What we are going to say?
Set life. Say life.
C'est la vie.
Yeah.
Exactly. So c'est la vie, it's the refractive index.
Oh, wow.
So it's a song. Yes, I know. Okay, for several people they sing a song like Shab Khalid or whatever. Okay, so refractive index equal speed of light in air, which is 3 times 10 to the power of 8 meters per second, over V, which is the speed in the medium, the speed through medium. Okay, through the medium. This ratio, okay, is the refractive index, speed through the medium. Okay, so what's the unit of refractive index? Meters per second over meters per second. It doesn't have a unit. Okay, unitless. There's no unit for it. Okay, it's a ratio. Tamam? Good. So C over V for any refractive index, like for glass, okay, certain type of glass, always it's constant value. Okay, it changes when we change the frequency or the light, or we change the glass. So that's why each material, like diamond, okay, several types of diamond, they know how good or how pure is the diamond, okay, how expensive is the diamond, okay, according to the refractive index of it. Okay, tamam? Good. So another formula for refractive index is this formula. It's also the ratio between the speed sine I over sine R, sine of the angle of incidence divided by sine of what? Angle of what? Refraction. So we have two formulas to find the refractive index, or to use the refractive index to find the speed of light or to find the angles. That's it for today. We are going to continue about refraction next time. If you have any question, you can stay online. If you don't have a question, you can leave. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you.
You are
Goodbye.
welcome. أهلا مع ألف سلامة. Bye bye.
Goodbye.
مع ألف سلامة. Bye bye. Any question?
Yeah, sir. N equal C over V. What is N? The N is the refractive
Is the refractive
index, right?
index? Yes, the refractive index.
Okay, thank you.
You are welcome. Bye bye.